are the two equivalent? And here, I had no idea on how to prove that just like that. So one of our engineers, who is probably here in the room, decided to use alloy that was mentioned in the previous presentations to try to verify the conjecture. The conjecture we had to try to find if we could find something about it. So alloy is a specification language. I won't speak too much about alloy, but basically that's one of the nice tools for model checking that are relatively simple to use and that are easy to put in place. What does it bring is that it brings you the possibility to explore in an exhaustive way all the possibilities as long as you are able to define a small user scope. And here the user scope is the number of the number of conditions in your decision. But the really interesting feature about alloy is that it produces counterexample when you have your conjecture is wrong. Not only it tells you my conjecture is wrong, but it tells you, gives you an example of why it is wrong. So what our engineer did is that he modelized the binary decision trees and MCDC requirements using alloy, and he started to verify those conjectures in the limited scope, which is to say with decisions that are never above 5 or 6, because after that the computing time becomes prohibitive. And actually we found out that all the conjectures that were wrong, it was extremely useful to have counterexamples coming from alloy to for our theory, because that's the counterexample that were given by alloy gave us the possibility to understand exactly what the real rules were. So first result is that when you're in the situation that the code generator and the restrictions on your language are sufficient, even in the best possible conditions, you will not have the implication that object branch coverage implies MCDC. That's what I mentioned first. And so the second conjecture was that if the decisions are limited to and then or else, then we were able to prove that object branch coverage is sufficient for MCDC, but in fact it is not necessary. That is to say, there are other expressions than those simple list of and then or else that meet our criteria. And so the question was, okay, fine. So now we know that it is not necessary, and we have counterexamples from alloy telling us even if you mix in certain ways and then or else, you can still deduce the fact that object branch coverage gives you MCDC. So we wanted to know more about that, because what we really want is to find when there is a perfect equivalence between object branch coverage and MCDC. For that, we had to limit ourselves to normalized decisions. So the NNF is for non-negative form. So you have to normalize your expressions by just pushing all the nodes inside your condition the most possible using the standard the Moore law. No, sorry, the De Morgan law. Sorry. And once you have that, we have found the real rule, and now we have proofs of that. We know exactly that if you have a decision that is composed of two sub-decisions with an and then between those two sub-decisions, then if there is no nor else anywhere in this sub-decision, then this kind of decision altogether meets the criteria that OBC will be equivalent to MCDC. That is to say, and that has to be recursive, obviously. That is to say, as soon as you have a and then somewhere, you cannot have or else on the left side at any level of your decision. Same thing in the other direction. If your main binary operation is or else, the only constraint you have is you must not have any and then on the left side of that at any level recursively. And so with alloy, we were able to show that this property is true for any decision up to 7. I think we stopped at 7 or maybe at 6. And from that, we were able to make a manual proof that this formula here is correct all the time. So for us, it gives us in the context of the project couverture, it means that if the compiler is able to detect those things, we don't need to do anything else than what is provided by object branch coverage to ensure MCDC. And and obviously we have implemented another way of treating MCDC here for all the operations, all the decisions that are not in that category.